In this lesson, we are going to look at how can we identify and unknown chemicals using the concept of precipitation and stoichiometry. So here is a common scenarios. Basically, you are given the mass of an unknown compound. And one thing we know about that unknown is that there is an ion that we know. So its unknown ions belong to this unknown compound. And then we are given a list of possible compounds, which one of the compounds will be the unknown. So what we're going to do is we are going to look at the solution and how we combine the two solutions together to make a precipitate. And in that precipitate, we'll have your known ions. So of course, the first step is to mix that solution. And from there, we are going to get our net ionic equation. But before we start moving on to the next step, let's look at the scenario more specifically. Here I have an unknown samples of alkali chloride. Has a mass of 1.62 grams. To find its identity, we treat with excess amount of 35.00 milliliter of silver nitrate. So in this case, I'm missing a 3 on silver nitrate solution. Now, after the reaction has completed, we collect 5.5 grams of pure precipitate. Identify the unknown alkali chloride. So the way it works is that, first of all, the word excess, that means you are treating with an excess reactant, so that way all the chloride ions will be completely reacted with excess. So we know alkali is in group 1A, so we know it's going to be an alkali metal, and it has a charge of +1. So Cl, we know that chloride has minus charge. So we have this somewhat a solution of unknown, which we know that any compound with group alkali will be soluble. So we have that right there, soluble in terms of aqueous solution. And here we have silver nitrate. Any compound that has nitrate will be soluble. So in this case, we have Ag plus and NO3 minus. Notice how I forgot the 3 there. So we know that they are going to exchange the ion and make compound. First of all, what we have here is this metal ions, of course, is going to be soluble, so they're going to become spectator ions. Wherein right here we have chloride and silver that is actually insoluble. Because if you go nag and sag on the solubility rules, this is the silver part in LMS. So our compound is going to be AgCl. This is your precipitate right there. So this is the precipitate that we just collect. So in this case, we go back and get our net ionic equation, which we know is going to be Ag plus and Cl minus. And that is our net ionic equation. So this one right here is our precipitate. Exactly how much did we collect? It is 5.5 grams of AgCl. So that is step 1. And then from step 1, we can get to step 2. Basically, if we know the precipitate with the specific chemical formula, we can actually solve for Cl. And this amount of Cl is actually the amount of Cl in your unknown compound as well. Because notice how the reaction is completed. That means all the chloride ions will be used up to make this precipitate. So we just multiply. We know that this has the molar mass of 143.32 grams of AgCl. Notice how we have the molar mass of the precipitate, but when we look at the unknown, we don't know what is the molar mass, and that's the reason we couldn't find directly. That's why we have to use our precipitate. So let's continue. So this, of course, relative to 1 mole of AgCl that's coming from the molar mass conversion factor. That cancel out. Now we move on to the next step and solve for Cl, which in terms of mole ratio. So within this compound, I have 1 moles of that compound, which is AgCl, and in this compound, I have 1 mole of Cl ions. Okay? or just Cl by itself, it doesn't really matter. And then from there, we are going to solve for Cl specifically. From there, we are going to solve for Cl specifically. In this case, I have 1 mole of Cl using the molar mass. It doesn't matter if ions or not, okay? Because the electrons are extremely small. It doesn't affect the mass of the ions. So here we have the molar mass of chlorine, which is from the periodic table 35.45 grams of Cl. And then from there, moles of Cl cancel out, and we plug everything into the calculator, and we get 1.36 grams of Cl. This is the mass of Cl in your unknown sample as well. So if we were able to find the mass of Cl in an unknown sample, we can now actually compare it to the total to get our mass to get the percent composition in a compound relative to Cl. So which is relative to the total sample, we have 1.62 gram times 100 and turn out to be 83.97% composition of Cl in this sample. And then from there, what we have here is percent composition of Cl in this sample. And what's so beautiful about percent composition? And that is, for any specific compound, we can identify the identity of that compound using the percent composition. Because if we look at this compound in general, it will always have the same mole ratio, and therefore they will have the same percent by mass composition. So what are the possible chemicals that we can compare to? If we go back to the problem, we know it's an alkali chloride. So what I did was I go back to the periodic table and I combine with the chloride. So alkali, here we have lithium chloride, sodium chloride, potassium chloride, rubidium chloride, and cesium chloride. But the most common one, of course, is going to be the first three, because these three are very unstable. So the first three, we have lithium chloride, sodium chloride, and potassium chloride. So what I did was I go back and I solve for the percent composition of each one of those. So here I have lithium chloride, and I just relative to 1 mole. So that way I can just take the mass of lithium or chloride combined together from the periodic table. So here is the mass of 1 mole of chloride from the periodic table divided by the molar mass of this compound, lithium chloride, and give myself 80, and we get 83.62%. Doesn't that look very similar to that? Okay, so that's for lithium chloride. Now, what happened when we have sodium chloride? Now, I did the same thing. I find the percent by mass of chlorine in sodium chloride using the relative number of 1 mole. So I have 35.45 divided by the mole mass of sodium chloride, and I got 60.66%. That is a lot different from that one. So of course this is not going to be unknown. And then we have potassium chloride. In this case, chlorine again, 35.45, and this is the molar mass of potassium chloride. And look at this, we have 47.55. That is completely way off. So our identity of the unknown is gonna be lithium chloride. So in this case, this gives us unknown equal to lithium chloride. And that's all we have to do.